Hello ladies and gentlemen. What we're going to be talking about today is how to use our molar mass. So in last video we talked about what a mole was, that it's 6.02 times 10 to the 23rd particles, and then we figured out how to calculate the molar mass of a substance. So you should have your lesson 10.2 notes out, and again you'll be able to fill in the blanks. At the very beginning of that is like a bell work question, so it's kind of like an intro to this. You're welcome to try those problems. You can pause the video now if you'd like. You can try those problems. You should notice that there's, in fine print, there should be, like in the bottom right hand corner of those boxes, you'll see the answers there. So that way you can try the problem and you can check your answers. So we're going to go over kind of our sub-objectives and objectives really quick, so that way you know what you should know from this video. So sub-objective 1 says you should be able to calculate the molar mass of a compound. We practiced that in our last video. Then sub-objective 2, you should be able to use dimensional analysis to convert between units. And then our goal is to be able to convert between grams, moles, and particles of a substance. So those first 4 problems that I have for you are kind of some practice problems. You can pause the video right now and try those problems. And again, if you look in the bottom right hand corner underneath those practice problems, you'll see some fine print. Those are the answers that you should get. So you can try those to see if you're doing it right, and if you're not, you can obviously let me know, and I'll try and give you some help on your dimensional analysis. Remember, writing out kind of our work for the problem and also the answers. So we're going to start back with kind of a review on how to calculate the molar mass. So we're kind of about halfway down our notes page. So on calculating molar mass, remember, the molar mass of a substance is the sum of the molar masses of each element. So here's kind of an example that we did in our last notes page. Remember, what we did is to find the molar mass of magnesium nitrate, we basically added up, looked on the periodic table, found the mass of magnesium. Because there's only one of them, we used 24.31. Then there were 2 nitrogens, so we added the mass of 2 nitrogens. And then there were 6 oxygens, so we added the 6 oxygens. We added those all together and we got 148.33 as our molar mass. Okay, that's going to be a conversion that we can now use. 1 mole equals 148.33 grams. Okay, so let's look at our mole calculations too. Okay, so now that we can calculate molar mass, okay, now that we know how to find the molar mass, we're going to use that to be able to convert between moles and grams. Okay, so last video we converted between moles and particles. Now we're going to convert between moles and grams. So we know this conversion already. We know that 6.02 times 10 to the 23rd particles is 1 mole. But a new conversion that we're going to add is that 1 mole is also the molar mass of a substance. Now, anytime we have a new substance, the molar mass is going to change. O2's molar mass is going to be different than N2's molar mass. Why? Because they weigh different amounts. So they're going to have different molar masses. Okay? So we can convert from particles to mass if we convert particles to moles, and then we convert moles to mass. So it's going to be like a 2-step problem. So here's our mass to moles calculation. So again, when we use dimensional analysis, we have to identify 3 things. We have to identify what they want us to find, we have to identify what we are given, and then we have to figure out what conversions we can use in order to get from point A to point B. So the question is, how many grams are in 1.3 moles of titanium? And the symbol for titanium is Ti. So first thing is, we want grams. We have moles of titanium. So we're going to use the molar mass of titanium. So we'd look on our periodic table. Because titanium is just an element, I would just look below titanium. Its molar mass is 47.8 grams per mole. So I'm going to use that conversion. I know 1 mole of titanium is equal to 47.8 grams. So here's my given amount. I have 1.33 moles of titanium. Again, that's what was given to me. And it asked me for how many grams. Well, here's my conversion factor to get between moles and grams. So remember, we write our dimensional analysis. We're going to take this conversion factor and write it as a fraction. Okay? We can either put 1 mole of titanium on top and our 47.8 grams on the bottom, or we can reverse those and put our 1 mole on the bottom and our 47.88 grams on the top. Remember, how we decide what to do is whatever this unit is what we're going to put on the bottom. So this is moles of titanium here, which means I need to put 1 mole of titanium on the bottom here. So I'm going to set that up, and I'd write it out something like this. The reason I'm doing that, remember, is so that moles of titanium will cancel. Remember, those units are just like a variable. So we're going to cancel out those units, and that way I'll just be left with grams, because it asked me for how many grams. So those units will cancel out. Then I would just put in my calculator 1.33 times 47.88. And when I do that multiplication, I should get 63.7. That's my numerical value. Then my units will be the units that are left over, grams of titanium. That would be how I convert between mass and moles. So now that we have 2 conversions, okay, what I've done is I've put on your notes page something that I call a mole roadmap. Okay, this is going to help you convert between units. So here's what I want you to notice. In the previous problem, it asked for grams and we were given moles. So let's look at our mole map. All that you have to do from this mole map is you have to identify where you are and where you're going. We started in moles. We were going to mass, which is in grams. So, in order to go from moles to grams, I needed to use this conversion, and I've put that in there for you. So, you're going to use the conversion of 1 mole is equal to the molar mass in grams. Well, depending on what your substance is, you would have to figure out what the molar mass was. Okay? So, I have helped you out by putting what conversion you're going to use. Now, this conversion will never change. 1 mole is always 6.02 times 10 to the 23rd particles, or atoms, or molecules, depending on if your substance is a molecule or an atom. So this conversion will never change. Going between moles and particles will always be the same conversion factor. It just depends on which way we put the fraction. Do we put 1 mole on top or on the bottom? But between here, molar masses will always change. Anytime you change a substance, if it's carbon, its molar mass in grams is going to be 12.01. If it's nitrogen, if I only had 1 nitrogen, it would be 14.01. If I had something like hydrogen, okay, just 1 hydrogen would be 1.01. Okay, so you see how like those molar masses will change depending on what my substance is. So you can use this to convert. I'll keep referring back to this so that I can help you guys with these conversions. So here's our next problem. Okay, so in our next problem, we're going to try and find what the mass is of 2.55 times 10 to the 23rd atoms of lead. So again, we have to identify what we want to get. We want grams, which means our ending unit should be grams, and we have atoms. Well, let's refer to our mole map here. It asked for atoms, okay? Particles, atoms, and molecules, remember those all kind of fit in down here. It asked for atoms, or excuse me, it gave me atoms, and it asked for the mass in grams, which means I'm going to have to convert from particles to moles using this conversion factor. Then I'm going to change from moles to grams using this conversion factor. Okay? So, here's how it would look. I start out with my unit I'm given, 2.55 times 10 to the 23rd atoms. I write that down. Then I think about, okay, on my mole map, in between particles and moles, I have to use the conversion factor of 1 mole equals 6.02 times 10 to the 23rd particles, or atoms. Well, because this unit is in atoms, I need to put my atoms unit on the bottom, which would be my 6.02 times 10 to the 23rd. So I put that on the bottom, and I put 1 mole on top. After this conversion factor, if I stopped here and just did this math, if I did 2.55 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and had those in parentheses, remember? If I stopped here, I would be in moles, because these units here, atoms of lead and atoms of lead, would cancel out, and I would be left with moles of lead. But I don't want moles of lead. Remember, the problem asked me for the mass of lead. So here's where I have to use my next conversion factor. And my next conversion factor is I have to find out the molar mass of lead. In order to go from moles to mass, or moles to grams, I need to know the molar mass of lead. Well, if I look at my periodic table, I'll find that the molar mass of lead is 207.2. Okay? So then I have to ask myself, I know that 1 mole of lead weighs 207.2 grams. Well, how am I going to put that conversion factor? Well, here's how you decide. Remember, these units are going to get canceled out. Let's see if I have them canceled out. Yep, these units are going to get canceled out. So the unit that I have here is moles of lead. Well, the conversion factor I'm going to use is 1 mole equals 207.2 grams of lead. Well, this unit is moles, which means I want to put the mole unit on the bottom here. So I'm going to put my 1 mole on the bottom and my 207.2 grams of lead on the top. Notice how moles here, I've got moles on top and moles on bottom, so those are going to cancel out, and I'm going to be just left with grams of lead, which is what it asked me to find. Now I just do my math. So I do 2.55 times 10 to the 23rd in parentheses, divided by, because this number is on the bottom, so I divide by it, divided by 6.02 times 10 to the 23rd, again, put that in parentheses. Then I multiply by 207.2, because the 207.2 is on the top, so I'm going to multiply by it. And once I did all of those, my final answer should be 87.8 grams of lead. And that's how you do a conversion between atoms and grams. Okay? Let's look at one more. So now it says, how many O2 molecules are present in 0.47 grams of oxygen gas? Okay? So first thing we need to remember is O2, or oxygen gas, remember, is O2. So it told us that in the problem, but it may not do that sometimes. If it says oxygen gas, you have to remember that that means O2. So what are we looking for? In other words, what are we trying to find, and what are we given? Well, we want molecules of O2. That's what it asked us for. We have grams of O2 because that's what's given to us. So I'm going to use my conversion factors, and I'm going to need Avogadro's number. Okay, because remember, if I go back to my, because I want molecules and I have grams, I need to look at my mole map. I have grams and I wanted molecules, so now I'm just going to go the opposite way of the previous problem. I'm going to start here. In order to change from mass to moles, I'm going to use this conversion factor. In order to change from moles to particles, I'm going to use this conversion factor. Okay? So let's look at it real quick. So I'm going to start by putting my given unit down here. I have 0.47 grams of O2. In order to change from grams, so on my mole map, I'd go from grams to moles. In order to go from grams to moles, I have to use the conversion factor of 1 mole is equal to the molar mass in grams. Well, what is the molar mass of O2? Well, oxygen is 16, but O2 is 16 times 2, which would be 32 grams. So I'm going to have to decide, do I put that 32 grams on the top, or do I put it on the bottom? Well, how I decide that is by looking at this unit of my given information. It's in grams, which means I need to put my grams on the bottom. So I'm going to put 32 grams on the bottom, my 32 grams of O2, and I put 1 mole of O2 on the top. So what would happen here is these units cancel out because one's on top, one's on the bottom. Next step is I need to get to molecules. Well, I know that 1 mole of O2 has 6.02 times 10 to the 23rd molecules in it. And again, now I'm going down from moles to particles on our mole map. So I see moles here, which means if I see the mole unit on the top, that means I need to have that same unit down here on the bottom so it can cancel out. Which means I'd put my 1 mole of O2 on the bottom, and I'd put my 6.02 times 10 to the 23rd molecules of O2 on top. And again, these units are now going to cancel, and notice how the only unit I have left is molecules of O2. And that's what it asked me for, how many molecules of O2. So then I would just put in my calculator, 0.47 divided by 32 grams, or I guess I don't need grams, just 32, times 6.02 times 10 to the 23rd. Okay, and make sure you use parentheses around the 6.02 times 10 to the 23rd. And you'd get 8.84 times 10 to the 21st molecules of O2. That would be your final answer. Again, I get my numerical value by either multiplying or dividing all my numbers, and I get my unit from the only unit that doesn't cancel out. Okay, so notice how I just take this molecules of O2, and that's my unit. Okay, so this is it for our lesson 2, which is over converting between moles, molar mass, or using moles, molar mass, and particles, and converting in between those. So hopefully you learned those things and accomplished our objectives, which means you should be able to calculate the molar mass of a compound. You should be able to use dimensional analysis to convert between units, and those units that you should be able to convert between are grams, moles, and particles. There's some practice problems at the bottom of your notes page, and again in the bottom right hand corner there should be some fine print down there that will show you the answers. I encourage you to try those, and if you need some help, make sure you let me know. Thanks for watching.